Okay, now we will have to fit the model. So we want to fit the model by using a LM. So LM is linear model. So we want to fit response variable tiled. So we're gonna tiled predictor variable plus predictor variable 2, then plus additional one because it's a multiple, then comma data. You can use as many as predicted variables as you want. So then data is equals to data. They close the bracket or parenthesis. So this is how we usually do it. So the meaning is the linear model, which is the name of the model. So then you want to the response variable, which is the MPG. So tiled the predictor variable. So the predictor variables, we want to use the like 4 variables, the displacement, HP, and DRT. So these are 3 variables, then comma data equals to data. So now let's write it in a real programming language. So we just wrote this for you to understand it. So now we don't write it and you like what we're doing. So you say model, you name it, you give it a variable name called model. So linear model, then you use MPG, which is the one you actually using the variables to give a response to. So you want to get a response of the MPG by using the predictor model. So what do you do? Then child displacement, then plus HP plus DRAT. Then if you want to use more, you continue to use plus. That's the way you do it. Data equals to data. So that data is the name of the data set. So that's why you use data. So whatever the name of the data set is, then you use it. So when you check everything is set, you click on one. So if it's not bringing out error, that means everything is fine. So you want to check assumptions of the model. So before you proceed, it's good to check the output of the model. So you also need to check that the model assumptions are met. When you assume to get the model, you get it. Namely, if we need to verify the following, what do we do? Among the things we do is one, we need to use a good visualization for this. So we can check the assumption by creating a simple histogram. So that's the reason why visualization is very good in data analysis or data science. So the very good way to do this is plotting an histogram by writing hist. Then we do the residue. So the residuals, then the models, then column, you want the color to be, let's use the color to be blue. Or let's use a gray color. This time I'll use, let's use a gray color this time around. So, but I usually like to use a red color. The red color is very, it's cool to be used. So you close it. So when you can check the, if you can check properly if everything is set. If it's set, you run it. So now we have the histogram. So the histogram can give you some information about the data of what you want to do. So as you can see from this distribution, is slightly right skewed. So it's slightly right skewed, as you can see. So it isn't abnormal enough to cause any problems or cause any concerns. So it's okay, you can use it. So, and also we can also see the variance of the residue should also be consistent for all the observation. So, and the condition, which we know as scarcity, That's what we call it in in statistics. So the teacher said the violation of this assumption is when they're not the same, where there's no consistency. So, and you want to check if that is correct or not correct. So you want to use what we call a fitted model. There is a model called a fitted model. So let's create it. Let's create a fitted model. Let's create the fitted value versus the residual. So the plotting is going to give you a good understanding. So you plot the fitted model. So against the residual model. So once you do this, so it's going to give you some additional information. So if you want to add some horizontal line, you can as well add some horizontal line. Add horizontal. You can add some horizontal line to the 0. Let's say you don't want the n to be 0 because some might go negative. So there's something about fitting things, some might go negative. So if you want to have a look at all of the points on your graph or on your visualization, you can use, instead of having the last value to be 0, you can have something less than 0. So now let's take a look here and let's run this and see if it's going to work. There's a problem here. So it says okay, I did not close my, sorry for that. So there's another, it couldn't find a residual. I think, let me check my spelling. Residual, sorry. So now we have it. So as you can see, from these, we would like the residuals to be equally scattered at every fitted value. We can see from the plot that the scattered tend to become a bit larger. So for larger fitted values, but this pattern is not extreme enough to cause any problems. So I think we can still go with it. So now we want to interpret the model. We already fitted the model, we've run it already. Now let's have an interpretation for it. If you want to interpret the model, it's pretty easy. In R, just call summary. Sorry, let me write what we're trying to do. In interpreting the model. So you want to interpret the model. So you say summary model. So this will summarize everything, summarize all the statistics for you. So now you would see the power of R. So now you say it gave you all the information you need to know about it. So from the output, we can say the overall F statistics is 32.15. And the corresponding P value is 3.28 raised to the power of -9. So that indicates that overall model is statistically significant. So I think you know what significance is. So it's statistically significant. So the meaning is the regression model as a whole is useful. And also the displacement, let's look at the displacement here. So the estimated estimate is -0.019232. So what does that mean? Is also statistically significant at a 0.01 because it's so, and in particular, the coefficient from the model output tells that a 1 unit increase in displacement is associated with the -0.19 unit decrease. So I mean the average in MPG, assuming the HP and the DRT are constant. So if the HP and the DRT are constant, then it's fine. And you can see the significance is been very obvious here. So now the HP, as you can see, is 0.03. So it's still a bit higher than the that of this. So it is also still very significant. So HP is statistically significant. So at the age 0.01. So it's still significant at that value. So and 0.03. And also, as you can see, the standard error is 0.01 here. So it's still very okay. So in particular, the coefficient from the model output tells that a 1 unit increase in the HP is associated with these with a negative 0.0031229 decrease on average. In MPG, assuming the displacement and the DRT is kept constant. So that's the meaning of this. So, and the DRT also is statistically still significant at 0.01. So, and in particular, the coefficient from the model output tells you that 1 unit increase in DRAT is associated with a 2.714975 unit increase on average in MPG, assuming the displacement and the HP is kept constant. So this is an amazing work, as you can see, and it's telling you the all significant. So if you want to have more information about it, then we can continue to run more analysis. But as for days, we want to call it, we've done enough here, we've run the model. So this is exactly how you can do your multiple linear regression model and how you can fit it. I hope you all benefited from this. Thank you very much for your time.